The lesson outcome for this video is, I can graph quadratics using a table. Now first I'd like to remind you that we have already graphed functions using a table, and that can be seen over here. Okay? We have graphed linear functions. And we use a table of values. We put in values for x, and we found their corresponding y value, and then we were able to graph it. A linear function has several different ways that we can write it, but one way we can write it is in y equals mx plus b form. And in this case, we have y equals 1x plus 3. So with this linear function right here, you'll remember that we've done this in previous units. We would plug in the -2 for the x value, so we'd have 1 times -2, which is -2, plus 3, which ends up being 1, and that's our output. So when we input -2 for x, we get an output of 1 for y. And then we plotted that over here at -2, 1, which is this point right here. And that's how, after getting a set of values, we were able to graph a linear function. So we're going to do that same thing in this unit, but we are going to be graphing quadratic functions. You'll notice that quadratic should sound familiar because we've been working with ax squared plus bx plus c expressions in the previous unit when we were trying to factor quadratics. So if we include a y equals in front of this, now we have a quadratic function. And whereas a linear function graphed as a line, a quadratic function will graph as a parabola. And a parabola is a U-shaped curve that is shown right here. So this is a parabola. A quadratic function will always graph as some sort of U shape. It might be opening down, as this one is, or it could be opening up in a different location. And we will be graphing those in the next two examples. One word that we should be familiar with during this unit is the word vertex. The vertex of a parabola is the either uppermost or lowermost point, depending on which way the graph is opening. Since these arrows down here show that this parabola will extend infinitely or forever in these two directions, there's no lowest point on the graph. But for this parabola, there is a highest point on the graph. That point right there is the vertex. All right, let's try an example. What we're going to do here is exactly what we did with linear equations. We're going to make a table of values, we're going to plot the points, and then we're going to connect those points. Now it used to be, again, with a line, and now it's going to be with a smooth curve, a U-shaped curve. So let's take a look at this first one. A lot of times we would start with, in linear, a set of values for x. So for example, -2, -1, 0, 1, and 2. So we're going to go ahead and start with those x values for this quadratic situation. Now again, let's remember, I didn't mention this on the previous screen, we know this is quadratic because it has an x squared term, and therefore it is quadratic. All right, so we're going to go ahead and put a -2 in for x. So y equals, instead of x, we're going to put a -2 in, squared. All right, so we need to do -2 squared, and -2 squared is -2 times -2, and -2 times -2 is +4. So we're going to plot our first point at -2, 4. Okay, -2 for our x-coordinate and 4 for our y. Again, just like with linear, a lot of times I would write that point right here and then plot it. So -2 on the x-axis and 4 on the y-axis is this point right here. Okay, so 2 left on the x-axis, 4 up on the y-axis, right, would meet right there. Let's try another one. Let's put a -1 in for y. So -1 squared. -1 times -1 is +1. So our next point is -1, 1. I'm going to put a point at -1, 1, which is right here. Now, if you stopped after just 2 points, you would probably assume that this is a linear graph. But it's not going to be, which is why we need some more x values. So next we're going to put in 0. So y equals 0 squared. Well, 0 times 0 is 0. So we have a point at 0, 0. And now you can already start to see that this is not going to be in a straight line if we were to connect these 3 points. It starts curving. Let's put in a 1 for y. So we put a 1 here. I'm sorry, for x, my bad, sorry. Y equals 1 squared. 1 times 1 is 1. So now we have a point at 1, comma 1. Well, 1, comma 1 actually brings us back up into this positive region of y values. So there's 1, comma 1. And the last one we're going to put a 2 in. So y equals 2 squared. 2 squared is 2 times 2, which is 4. So our last point that we're going to plot is 2, comma 4. 2, comma 4, well, 2 on the x-axis, 4 on the y-axis will give us this point right here. So as you can see, these points do not create a straight line, but a U-shaped, if you can visualize that right now. So if I kind of came through this point, curved around through this point, and came back up like this, that would be my parabola. The vertex is this point right here, which we're going to talk a lot about in the coming days. So remember, that is the vertex. It's the lowest point of the graph. Okay, let's try a second example that has a little bit more work to it. So this time we have the equation y equals x squared plus 4. All right, we're going to go the same route. We're going to put some values in for x, and we're going to find the corresponding output y. We're going to start with negative 2 again. So when we put a negative 2 in for x, we put that in parentheses to be careful, because if we compute that on our calculators, we'll need the parentheses. So negative 2 squared, well, negative 2 squared is 4. So this part right here, negative 2 times negative 2 is 4, and 4 plus 4 is 8. So our first point is negative 2, 8. I'm going to go ahead and plot that on my graph. Negative 2, 8 is this point right here. All right, I'm going to go with negative 1 next. When I plot that, or put that negative 1 in for x, I'm going to use, again, my negative 1 squared, use parentheses here. Negative 1 squared is negative 1 times negative 1, which is 1, plus 4 is 5. So my next point is negative 1, 5. Negative 1, 5 is plotted 1, 2, 3, 4, 5 right here. Then we're going to go ahead and put 0 in. We put a 0 in. Zero squared, 0 times 0 is 0, plus 4 is 4. So our next point is 0 for our input and 4 for our output. 0, 4 is this point right here. 0 on the x-axis, 4 on the y-axis. Now we'll put a positive 1 in for x. 1 times 1 is 1, plus 4 is 5. So we have 1, comma 5. The point 1, 5 is found right here. And lastly, I'll put in a 2, so y equals 2 squared plus 4. 2 squared is 2 times 2. 2 times 2 is 4, plus 4 is 8. You probably have noticed that there's a pattern that shows up with our y values when we use these x values so far. 8, 5, 4, 5, 8, which is shown in the graph with a symmetric look. If you think about symmetry, remember that like a heart shaped is symmetric because if you fold it along this line, it's the same on both sides. So that's what's going on here too, is it's symmetric. And a U is always a symmetric shape. So you've got the 2 points right next, across from each other from the axis line here, and these 2 points as well. So it's symmetric. That's another word for us to talk about during this unit. But now we can just draw our curve shape through these points. It takes some practice. And it should look like a U shape. Try hard not to make it look like a V. If you have got like some points like this, down here, if you can see this, I drew them kind of light right here, sorry. A lot of times people want to make a V shape out of those points, and it shouldn't be a V, okay? It should be a U-shaped curve through those points. If I had an eraser, I'd erase and try again, but that's good enough for this video, I think. Okay, and so we're going to do one last example here. And in this example, you'll notice that the quadratic equation looks a little different yet. All right, x squared plus 4x plus 3. We're still going to put some values in for x and find the corresponding y value. This time the x values I'm going to use are -4, -3, -2, -1, and 0. And this is just because I know how the parabola is going to look on the graph, and these are good points for us to use. And for a while, that's what I'll do in class, is kind of give you the correct x values to use to help you graph it quickly. All right, so we're going to put -4 in for x. And notice what you have to be careful of here. We're going to put -4 in for the x right there and square it. Notice we are going to put -4 in again right here because x shows up twice in our equation. So in this equation, x shows up here and here. This is the first time we've done this with a table like this, that we've actually had to put -4 in 2 different locations. All right, so now to simplify this right here, you can use a calculator. You can think about it mathematically and work through the simplification, whichever one you want at this point. All right, so I'm going to go ahead and simplify this by hand. So y equals -4 squared plus 4 times -4 plus 3. So y will equal, what's -4 squared? Well, it's positive 16 plus 4 times -4, and we're using the order of operations here, by the way. We're taking this and squaring it first, and then we're going to multiply here. So 4 times -4 is -16, and then plus 3. Well, now if we just add straight across, we get 16 plus -16, which is 0, plus 3. That will give us 3. So y is 3. Our first point then is at -4, 3. Plotting that, -4, 3 will give us this point right here. All right, so let's try the next one. This time we're going to plug -3 in for both x's. So y equals -3 squared plus 4 times -3 plus 3. So to simplify this, -3 squared, well, -3 times -3 is positive 9, not -9, plus 4 times -3 is -12, plus 3. Okay. So what's 9 plus -12? Well, 9 plus -12 is -3 plus 3. Well, -3 plus 3 is 0. So y equals 0. Our second point, therefore, is -3, 0. -3, 0 is this point right here. At this point, I'm running out of time on the video. If you'd like to finish it up and ask me to take a look at it in class, we can do that.